Hello, everyone. I believe it's time to start. So thank you for joining our webinar in this challenging time. I hope that time spent on listening us will be valuable for all of you. So my name is David, and together with Tomek, we would like to show you how well-defined strategy can affect the success of a project. Before I move to the next slides, I would like to ask you to use questions tab. If you want to write questions for us, please don't use chat, we don't monitor it. Also, if there will be many questions and we'll not be able to answer them during this webinar, so don't worry, we will publish them as a blog post in the actually next few days. Yes, indeed, it will be shared and recorded and shared later. Sure. So let's start. Going through this webinar, we would like to give you an answer for these 5 questions you just see. So first thing, the importance of QA. The second one, how to create the high quality product and not to go bankrupt. Then how to choose the right type of test. So talk a little bit more about it. Then he will show you differences between quality assurance and the quality control. And at the end, he will also tell you about the non-standard approach, I believe, in software testing, the different layers that are not that popular in our opinion. So first, I will start from the business side, and then, of course, Tomek will go through the basics of testing, and then he will end up with more technical topics related to the test automation. So in details, I would like to speak about the importance of the quality. I would like to give a couple of definitions of the quality. We'll speak a little bit how you should estimate the cost of quality. And at the end, I will tell you also how expensive can be a poor quality product. I have a couple of examples. And then Tomek will talk about the importance of choosing the right strategy for the quality assurance. He will speak based on his experience. So he will talk a little bit about the standard approaches, both proactive, so the quality assurance, and also the reactive, so quality control. And finally, he will focus on quality control part where he shows these less standard testing approaches and explain actually when it's worth experimenting. So I will start from the question to you. Do you know what companies are afraid the most when they decide to start a project? I believe most of you will give probably the same answer. So in our opinion, they are afraid that this project will not be implemented within the specified time or specified budget. Even if these parameters are met, the system's low usability is another concern of the company. So by usability, I mean actually the functionality, the performance of the application, scalability, reliability, and of course, the application shouldn't have any critical errors when it's live in production. And the last fear is that the system doesn't provide any business value, even if it will be working well. So how to avoid it, actually? So the simplest answer is by ensuring the high quality of the product, actually. However, as you may see, the temptation to take shortcuts in the software development process wins in many cases. And as a consequence, a lot of projects fails. To increase the likelihood of a project success, we should focus on providing the high quality product, hence choosing the right QA strategy for such project. Let's talk a little bit about the quality itself. So most software development companies advertise that they create high quality products. And what does exactly means the high quality product? More or less, that the product they release meet their internal standards that they define actually, right? So the scope of the standards is defined by each company internally. For one company, a sufficient quality may be the test written and run only by the developers, so they don't need testers at all. And on the other hand, there are companies that are producing the safety critical products, for example, systems for the police, for army, for medicine, or for the aviation. And they must meet the certain quality standards. In the internet, if you will Google, then you find multiple definitions of the software quality. The ones that I really like is the short one. Quality simply is the suitability for use. Or the other definition, quality is the capability of a software product to conform to requirements, right? But the one that I really like has been defined long time ago by the IBM that says that quality is a well-defined process for creating a useful product that adds value for both the consumer and the manufacturer. And for me, this is the best definition that I found. Why? Because well-defined process can minimize the risk with the fear that you will exceed the time and or the budget, because in well-defined process, everyone knows what is his role, what he should do at a given stage of the project. Then, useful product. So that's what I said. The product should be functional, should perform well, should be secure, shouldn't have any critical errors. And the last one that I highlighted, adds value, which means that brings business value. So this is the best definition of a quality, in my opinion. So when we speak about the quality, probably many of you think, okay, it's perfect, but how does that cost? So let's speak a little bit about the cost of quality. Normally, we can measure it by time or effort, but however, the money is the main factor that can convince everyone. So we can divide quality for two parts, the cost of quality for two parts, as a cost of good quality and cost of poor quality. Let's focus first on the green part, cost of good quality. It consists again of another two parts. First one is the prevention costs. So these costs are it's related to all proactive decisions like improvements of development or testing processes. It's simply cost of QA strategy that you define. The second one, appraisal costs. In the other word, it's called inspection costs. It's associated with measuring and monitoring activities related to product quality, like defect detections, order reviews, unit tests, integration tests, system tests, or even acceptance tests. So it's simply all about the quality control strategy. And on the other part, we have a cost of poor quality that we don't have much influence how big it will be. So the first one is the internal failure cost. This cost is related to defects found internally and all efforts to correct them. So all the reworks, retests. And this, of course, involves many people, right, in your team. Developers, QAs, maybe DevOps, even PM, if it's needed to control it. And the last one, external failure cost. These are the costs related to defects identified by the client or end users in a production. And of course, the efforts to correct them. As you can imagine, these costs usually are very huge. So in an effect, this is not only money loss that is a problem here, but also reputation or even life. And in the next slides, I will show you a couple of examples what kind of consequences of poor quality may be. The first one, I would like to highlight the issue that happened on the Heathrow Terminal 5 opening. It was related to the baggage handling software for Heathrow's new terminal. It was some time ago, actually, in 2008. System was tested. However, the testing didn't take into account real-world usage, which is where the system failed. So as a result of the failure, because of the low workload and the specific cases that hasn't been tested before production, in the result was thousands of bugs left behind while the flights left. Actually, it was over 42,000 bugs that failed to travel with the owners, and also over 500 flights were cancelled. So this crisis could cost the airline around 50 million US dollars. The second example I would like to show you is about the Knights Capital Group system that started training about 150 stocks erratically, leading to a 440 million US dollars loss in half an hour only. But this is not counting the loss when they occurred when the shares actually went down by 75% in the next 2 days due to this. So this is also the little bit the reputation as well, right? And the last one that I want to show you because of the time constraints, it's related to the US Patriot missile defense system that was installed in Saudi Arabia that failed to detect an attack on an army barracks. And after this happened, the government report found that a software problem led to an inaccurate tracking calculation that became worse and longer the system operated. So on the day when the incident happened, the system had been operating for more than 100 hours, and the inaccuracy was serious enough. They say it was about a third of a second to cause the system to look in the wrong place when the incoming missiles attacked. So as an effect, 28 American soldiers died. So as I mentioned, so whenever the external failure occurs, it's not only about the money itself, because you cannot value the human lives, right? So just to highlight, if you think about successful project, don't take shortcuts. Think about the quality of your product. So if we speak about developing high quality product, how to do it right? As I mentioned earlier, the cost of good quality is usually a considerable expense from the customer's point of view. This is especially in large projects. Such projects, of course, require a lot of specialists working together, hence they need to communicate effectively, and they need to work in an efficient way. So how to ensure this high quality product while not going bankrupt? Again, the simple answer is a well-considered QA strategy that comes in handy here. So first thing, preventive methods. I would suggest to think about well-defined process, as I mentioned in the definition of the IBM, of the definition of the quality, where everyone knows what to do, what are the expectations from them, what are their roles and responsibilities. Think about quality standards you define for the project. So again, don't take shortcuts. The second one is to choose the right approach to testing. It's all about the good quality control strategy when we speak about the product itself, not only the process itself. Even before the start of the project, decide on the appropriate level of tests, the quantity and the approach. The last one I would like to share is the test automation approach. Invest in it, but remember about return of investment. Don't try to automate everything. So actually, that was the beginning. So my part of this webinar ends here. I hope that I showed you some business perspective, how the quality may influence the project? What are the consequences of poor quality? And now Tomek will share his experience related to the QA work, the process improvements in the projects he worked on, as well as he shows you that it's worth experimenting with different kind of tests. So Tomek, it's your time. Just stop sharing.
Everyone, let me share my screen. It's hopefully gonna be this one. Or give me a second, please. The technical issue of having it on different computers. Okay, there we go. Okay. Okay, hopefully you see my screen. Hello everyone, my name is Tomasz Górski and I'm Senior Quality Assurance Engineer in the software house. And I would like to talk a bit how I started my career. And so when I started my career, I always wanted to be a good tester, but I didn't really feel what it means. I thought it's somehow related to finding all of the issues, and I didn't really think about the process itself. And because of it, I learned some habits like this behavior is good or this behavior is bad. And at this moment, I would like to ask you a question. Have you ever made a decision just because something worked in your previous project without really thinking if it suits your current needs? And my answer is, I did that mistake. And I think probably most of us did the same mistakes, because most of us say, I had no time, and probably no one else has the time. And at this stage, if you did this mistake, I would like to ask you another question, which is, do you have time for making reckless decisions? And then perhaps you say, our client didn't give us a time to better investigation or for a planning stage. And my question is, did you actually ask? We usually assume that somebody gonna say something, and finally we never ask the question. And this is bad, because at the end we share the same goal, which is the success of the product. And today we are gonna talk about making the right decisions that suits your current needs in your project. And the main topics are gonna be about the QA role in the team, the differences between QA and QC. And I will give you an example on the project that we had in TSH. And finally, choosing the right QA strategy, how we improved our process, and what was wrong with the previous one, and type of test that maybe you haven't heard about, and the good and bad practices that we experienced. And by failing to prepare, you're preparing to fail. And I fully agree with that. I assume you that decisions made at the beginning of the project are critical, and avoiding, for example, the planning stage might make your life very difficult, while preparing well to the project might make your life.
Tomek, sorry to disturb you, but I believe we don't see your next slides.
Okay.
We just see the misunderstanding and communication, but I believe you speak about another one.
Yeah, that's true. Sorry for that. Let me try to start the streaming again. Okay, this. Okay, it should work now. So before we start, actually, let's compare the QA and QC approaches, the quality assurance and quality control, and the main differences between them. So QA approach is proactive, that is process oriented, and QA role is about caring about the development and test processes. But what does it mean? It means that QA job is to prevent as many defects as possible before application goes live, while the quality control approach is more about identifying issues on the finished product. And it's more reactive approach. So let's take a look maybe on the business side and what our client may be the most afraid of. So in our opinion, businesses mostly fear that the application will have low usability. And because of it, in my opinion, QA should be a member of the team since you discuss the project specification, where you define the standards, and then you make sure that everybody in the team understand the business goals, and people will follow these rules that you defined it at this stage. It also worth to remember that you can't test everything, and you always should keep in mind the term of return of investment. And there is a good practice that people usually don't follow, is to put yourself in the role of the end user and then test the application this way. And let's maybe show the basic flow, how it might look like. And here we have a very high level diagram, just a general perspective. And as you can see on the first stage, we have the planning. And what do we do here? So if you work in Scrum, you should, for example, define the acceptance criteria, definition of done, definition of ready, and make sure that everybody understand the business goals and agree to follow them. And the next stage is the test plan. So what the test plan is, it's generally a document which informs you what will be tested, what won't be tested, who is responsible for what, and so on. And it, of course, helps you to make sure that you and your team are on the same page with your business. Another important part is creating regression test cases. And why? There are a couple of reasons. For example, it's much easier to share your work and don't get duplicated if you are not alone in the team, as a tester. And thanks to regression test cases, you won't forget about testing any part of your system. And before we start talking about the automation, it's worth to remind ourselves that manual tests are expensive, slow, and for sure there are great chances for mistakes, as all testers are human beings. And therefore, we should implement the well-planned automation test to save time and money. So maybe let's remind ourselves about the goals of the automation test. So the main goal, in my opinion, of automation tests is to minimize risk of defects that might occur on the production. And David gave us an example of companies that took shortcuts and it didn't went well, right? And we learned that it's much safer to prevent issues and much cheaper than fixing them on the production. And in case of automation tests, we also must to remember about return of investment. It also concerns the automation test. And to make it clearer, you always must to think about probably three things. You must get a very quick feedback, because nobody will wait for hours for the results, and tests should be reliable. People will ignore tests that fail while the system works properly, and tests should have a decent coverage. At least most important flows from the business perspective should be covered. And to match all of these requirements, we needed a good planning session, okay? And regarding the planning session that we had in our project is, what if we had this planning stage, we already discussed who is gonna use the application, and we already know and understand the business goals. So at this stage, we are able to choose the correct tools. And for example, imagine the situation: if you build a modern streaming portal and you want to automate the user flows with end-to-end tests, for sure, you can remove Internet Explorer support from your must-have list, and perhaps you can search for different tools. And probably the most test automation tool, the most known test automation tool is Selenium. And however, I would like to convince you to maybe experiment a bit. I'm not against Selenium, of course, but you are not forced to use it, as you have many different great frameworks like Cypress, for example, Kakunin, Puppeteer. And what are the benefits of it? For example, if you are using Cypress, they give you a mechanism that record your test and generate the decent report, and you don't have to implement it by yourself. And thanks to that, you can focus more on the business needs. But there is also a thing that you should keep in your mind. Don't experiment too much on your client's product without having an experience with the new tool, because there are always risks. And we already started to talk about some mistakes the testers do. So maybe let's continue with this topic. And from my experience, I saw many projects where manual testers were testing the edge cases, for example, related to schema validation, okay? And they spent lots of hours to test as many cases as possible. And in my opinion, it's not good. And why is that? I will give you an example on Joy to give you a better perspective. What do we know about Joy? The Joy is the JavaScript tool that allows you to validate schema. And if you open the source code, you can find lots of tests created by Joy team. And going further, what does it mean? And it means that if you test every edge cases, you duplicate someone's work instead of doing what is important for your project. And I assume you cannot test every library that you have in dependencies, and you shouldn't even try to. In this case, it's really enough to check, to test it just with integration tests. And remember, the good communication is a key to the success, and developers usually know which part of the code might have some bugs and which is already well tested. I am not saying that you shouldn't test it, but you should maybe focus on the different part, right? And so, as I promised, I will give you example based on a project that we had in TSH. And I think we did a pretty good job here. I cut some statuses like rejected or to do, just to make this flow easier to read. And I saw some questions on the chat, so we will answer them after the presentation, so you don't get disturbed. So here we have a flow where developer take a task from to-do list, and then it goes to the in progress, right? And when he finishes it, the task goes to the code review, where just two developers' approvals are required for the merge. And it is okay, then the QA move it to the QA past. And if there are any problems, bugs, he just rejects it, and the cycle of flow is repeated. And this approach was fine as long as we were deploying new features once per 2 weeks, okay? And it was before a demo. But what was wrong with this process? There were some bad parts. For example, people never knew if their functionalities work together. And we had bugs on master branch. That's another problem. We had problems to find which commit and which PR committed, which PR affected the issues on the master. And it was because people were keep merging new pull requests just because 2 approvals of developers were required to do so. And then we spent a lot of hours to fix those things before a demo. So what it means? Actually, it means that we were always stressed before a deploy because we never knew if it's going to be succeeded or not. And at the end, we knew that our process isn't perfect, but we had a very close deadline. So we didn't want to experiment too much. But there is a say, stay committed to your decisions, but stay flexible in your approach. And finally, we changed the process. And it is because we met a great challenge. And the challenge was our client asked us for make more often deploys. So he can check every time actually when we finish a feature. And he didn't have time for waiting 2 weeks until we finish it before the sprint ends. He just wanted to be sure if we are going to the good direction. And we changed our strategy because we were flexible. We decided to make a retrospective meeting where every team member shared what was good and what was bad. And finally, the most important part, how to improve the current situation. And the meeting ended up with a draft of a new process that we started to follow. And this is actually how it looked after the changes. We added here the stage with test on a feature branch. And since that moment, testers were responsible for merging the pull request. And the rest of flow remained the same. And before the changes, actually we had, as a testers, more the quality control approach, because we were checking if the defect already exists on the master branch. And it wasn't optimal because fixing defects on the production is much more expensive than preventing it. So to improve it, we added that stage where we tested every new feature on the feature branch, and on that feature branch we were deploying it, and as a part of pipeline we had automation tests executed there, and we had to test only manually the part which is new. So it didn't slow up our process, but it allowed to make us but we were sure that the new feature is working fine. We had a huge benefits because of it, because we knew that master branch is stable, is always stable, and we weren't afraid of deployments. And it is because we were deploying new things at least once a day. And at this stage, I would like to say that it's better to say to your client that something is not finished than deploying the code that doesn't work. And to achieve all this thing, what strategy did we select? And before we talk about the strategy, maybe let's say what we wanted to achieve. And we wanted to make sure that our application works properly together, because I didn't mention it before. Our application was based on the microservices. So we wanted to make sure that every service communicates with each other well, they understand each other, and if, for example, one of their services go down, the application works fine after a while again. And at this stage, actually, the most standard approach didn't match all of our needs. And that standard approach is the testing pyramid. Probably most of you know it, and it didn't match our needs just because our application was based on the microservices. And we wanted to have maybe more integration tests because, as I said before, we wanted to make sure that all the pieces work together, not just the parts in isolation. So, and we decided to spend maybe a bit more time for research to find a better strategy that suits our needs in case of having application based on microservices. And here we found the testing trophy strategy. And as you can see, the integration tests are the key that the strategy focus on. And there are fewer unit tests, but we were okay with that. End-to-end tests here are also the smallest part, as it's the slowest and probably the most expensive test layer. And as an additional thing, we have the static code test, and we will discuss it today later on. And so, as I mentioned, we decided to choose the testing trophy strategy and focus on integration tests. And our main goal was to focus to make sure that system works with all the pieces together. And to give you a better perspective, we wanted to make sure that, for example, user can log in, and it includes also the test of security service, of database service. Check if this user have access to the chat. And then, if this user is able to send a message on this chat, and then what happens if administrator close or reopen the chat? What happens if somebody block this user? And finally, what happens if one of the services went down and, for example, AWS bringing up? And we wanted to be sure that then it works properly. And to achieve it, actually, to make sure by our test that it works, we had most tests without UI, without user interface. But we also added some tests in Puppeteer where we use Chrome browser to simulate the user behavior. But we tested the modules, let's say, in isolation. We just had to inject some data to set the state of application that we were able to make this operation. We hadn't have many pure unit tests. Of course, we had them in case we had the testing trophy, testing pyramid approach in case of each microservice. But if you watch the general perspective of the application, we have the testing trophy approach. But we also had the end-to-end test that I mentioned before, and we had 3 challenges here. First of all, we had to support Internet Explorer 8 because our clients, it was required to have it. We have to have results in 15 minutes, but making it even more difficult, we have to generate test data every time we run the test because our application were changed dynamically and we didn't want to have fixtures. And we achieved it, right, actually, to have a feedback in 15 minutes. The tests were added to the pipeline and it did a really good job. But those are not all of the test layers that we had. And maybe let's talk about contract test because we also implemented it. And we are gonna talk it. I'm gonna give you some example in the next slide. So the contract test check. What are the test contracts? And the contract test check if the services understand each other. For the given input, you expect strict output. Otherwise, test will fail. For example, you have libraries like packed.io, and to give you the better perspective, you can imagine the situation where you add a new user to the system, okay? And first name, last name, and email address are required. And when you send all this data, you expect, for example, response with status 200 and with some data. And if you send, for example, the request without email address, you expect that it will return error 400 with information that email is missing. And to achieve it, you can use the mock services or a real one. In our case, we used deployed services. We didn't have to mock anything, and we only had to set the application to the state that allows us to make operation, like, for example, sending the messages on the chat channel. And important part, if you focus on the contract test, is the contract test doesn't check the side effect, and you must have the integration test to make sure that your application works properly, okay? And we also wanted to have modules tested separately. We had some tests in Puppeteer, but we also wanted to make a maybe pure component test. And the component test, you might haven't heard about it, but they are also known as the module test. And to give you a better perspective, login, register, and chat are three different modules, and they should be tested in isolation. But you can ask, what are the benefits? You duplicate your work. So, in my opinion, like the benefits of component tests is to imagine the situation. You have, for example, 3 module tests passing: the register, the login, and the chat. But you have an integration test that failed. So at this point, you know where to look for the defect, because the case is not the defect doesn't exist in each of the module. The problem exists somewhere in integration. So it allow you to save a lot of time to find this defect and then save some money. But this is not all of the testing layers that we had implemented, because we wanted to have the feedback even faster. And to reach this goal, we actually had the static code testing. And for example, you can use the TS-lint, the S-lint, the SonarQube, and in my opinion, it's underestimated. And this is a very powerful tool that make all of the developers follow the same rules. That's the first thing. It tracks the most common issues. For example, you declared variable and you never use it, or more importantly, you use the value that weren't defined before. And thanks to this test layer, that static code test layer, you are able to detect it very quickly because it gives you an instant feedback. And at this stage, it's also worth to say something about type languages, for example, about TypeScript, because TypeScript won't allow you to pass, for example, the string to the method that requires an object, because then it's gonna return the compiler error. And from our experience, it's very, very good to use it, to use the static code testing, including the TS-lint and other tools with the typed languages, because in a big teams, it's gonna make you much more effective. So, summarizing all, to achieve a good quality of products, you should never take shortcuts. You should always remember about good practices and about the planning sessions, because it's gonna make your life easier. And finally, the proactive approach you might make your life much more easier, because then you save the time and money, and it's better to prevent defects than fixing them on real product that is live. And I say that it's good to rely on more testing layers, not just on the standard approaches, because it's gonna give you a quick feedback if your code is working well, and don't make your project bankrupt. And so, if you liked this webinar, I invite you to visit the website TSH.io newsletter, and there we share some articles about the business, about the leadership, and about upcoming webinars. And also, 2 weeks ago we launched the State of Microcell. This is 2020 report. We believe that it's the most actual publication about the microservices, and you can download the PDF report for free and check it by your own. And at this stage, this is everything from our side. Thank you for joining, and hopefully you learned something new, or at least we didn't bore you if you already knew all this stuff. And now we're gonna answer the questions that you asked on the chat.
I believe, Tomek, just to not extend the time, it's already 50 minutes. So let's just gather all those questions. And we, as I mentioned at the beginning, we'll publish the answers as a blog post in the next few days. That will be the best. So we'll give the detailed answers. Okay, so that's it for us. And once again, thank you very much for joining our webinar. Stay healthy and see you next time. Goodbye.